So we're now in my IntelliJ project for the EX37 case study. And if we pop down here a little bit, we're going to see that we have a main program like we always do. And this particular program is a variant of ones we looked at before, but this is really cool. It's going to take a look at all the unique words in Shakespeare, and it's going to keep track of how many times each word appears. And so it'll print all the words in Shakespeare that are unique and the number of times they appear, and then it'll also print the top 50 words in the complete works of Shakespeare. And of course, it's also going to time the results to show you what happens when you use concurrent collectors and non-concurrent collectors with sequential and parallel streams, and then use different types of maps, including hash maps and tree maps. So that's the way it's going to work. So let me just go ahead and start this thing running. It'll take a little while to run because it's processing a lot of words and doing a lot of work. Some of this looks a bit like the previous example we looked at with the concurrent set collector, but now we're going to have a concurrent map collector instead, which is a little bit more sophisticated than the concurrent set collector. So we'll take a look at that. Once again, we have this quad functional interface that takes 4 parameters and returns a result. It's all generic. We're going to iterate, in this case, for 10 iterations. We have the complete works of Shakespeare, as we had before, which is organized to the 37 sonnets and the 37 plays and all the sonnets. And it's about 5.5 megabytes. And if we come back over here, you can see that we have this regular expression that splits everything up. So we have words. We warm up the thread pool so that we're going to be able to get accurate timing results. And then we run this run map collector test method, which will test hash maps first as the collector type, and then tree maps as the collector type. And then we pass in parameters that indicate what we want the keys to be, which in this case will just be the words from Shakespeare. And then we pass in what we want the initial value to be, which will start out with the value 1. And then we pass in the types of containers or collections that we want to collect into, either concurrently or sequentially. And we're going to have HashMap and concurrent HashMap for the HashMap variant, and we're going to have TreeMap, which will, of course, end up also using TreeMap, and the concurrent map collector for the TreeMap version. So that's actually very similar to what we had before. And then when we're done, we're going to print all the results. And let's just have some fun and go take a quick look at the results. They should be done by now. So if you've ever lain awake at night asking yourself, what are the top 50 words in Shakespeare? Here they are. So the appears over 27,000 times. A lot of these words are just very simple words. These words, by the way, just a little bit of history lesson, are derived from Anglo-Saxon. When the Normans came over after the Battle of Hastings in 1066, they brought a variant of French that influenced what became English, but the Anglo-Saxons had a lot of the simple words. The more sophisticated words in English typically came from the Normans. The simple ones, like most of the ones you see here, are ones from the Anglo-Saxons. You can see that most of the words are words that are very much in common use today, but some of them, as we start getting a little further down, like thou, that doesn't sound like a word we use a whole lot, but Shakespeare would use it quite a bit, as you can see. Other ones like king occurs a lot, no surprise, because it's in England during that period of time. Lord, sir, thee, those are the kind of words that you would expect to hear in Shakespeare. So those are the top 50 words in descending order. And then these are all the words, and I'm not going to go through them, of course, because there's a whole bunch of them. These are all the words in Shakespeare and the number of times each of those words appears. So those are the results for that. Let's also, just for fun, take a look at the results of running this with the different variations of concurrent and non-concurrent collectors and parallel and sequential streams. As always, for a small number of n, parallel is slower than sequential. We've seen that before. As we start getting to larger numbers of n, then we see some interesting results. In this particular case, for instance, we can see that the non-concurrent version of HashMap was actually faster than the concurrent version. I have a feeling if we ran this a couple times, we'd see the results go back and forth. But that's kind of an interesting result. So that indicates, for at least this example, that concurrent HashMap is pretty fast at being able to combine results. And then when we take a look at the TreeMap example, you can see that the concurrent TreeMap is indeed faster than the non-concurrent tree map for parallel streams as we get larger n, but it's not wildly faster. So just some interesting stuff here to contemplate in the results. And again, as always, your mileage may vary. So if we run those again, we might get different results. So let's take a quick look at how we run these tests. So you can see here that we pass in these parameters. We pass in this method called time stream collect. And time stream collect basically goes ahead and runs the tests. And you can see we kind of factored out the tests here. And what test does is it goes ahead and creates either a parallel or a sequential stream. And then it maps each word to lowercase so that you don't end up with the with capital T being perceived as different from the with lowercase t. And then we collect those things into the appropriate collector that we passed in there. So that's basically how we run things in parallel. And here's the method that actually runs all the different tests for the different sizes of inputs. You can see it's very much like the earlier version that we looked at in the previous example. We get all the words of Shakespeare in the different sizes, and then we apply the different types of collectors. And you'll notice that this is the merge function we pass in, which just says if there are two things that have the same value, then just go ahead and add them together. OK, so down here, here's the print results method. This is kind of fun, too. Print results takes the map of all the results. And the first thing it does is it makes a string containing all the words. And so what it's doing is it's taking the elements in the map and basically taking all the entries in the map, a set of entries, and then it turns them into a stream of entries. So those are just basically the word and the count of that word. So like the would be 5,216 or whatever. It then turns those things into streams, and it collects them into basically a list of strings. So we have a stream of strings that are going to be collected into a list of strings. So we have a list of all the strings, just converting them into strings so we can print them out simply. We do a similar thing here, except this time we're going to sort the results by value. Keep in mind that what we want to know are what words occur most frequently in the works of Shakespeare. So we take the values in the stream, and we sort them in reverse order. So the words that occur more frequently occur at the beginning of this stream. And then we limit ourselves to the top S max words, which in this case is 50. And we turn those to strings. We collect that into a list of strings. And that's what we print out. So that's what gave us these results here.